This is going to be the last lecture, Basic Data Science Modules. This has been a pretty long notebook, but the final topic we want to discuss in the kind of basic Python data science stack is Pandas. Pandas is a very useful and powerful tool for working with data tables in Python. It's going to be almost analogous to Excel, but way more powerful. And we are going to be working heavily with Pandas for the remainder of the course. And when we dig into it in the Pandas lectures, in the Pandas notebook, we'll explore the various filtering and grouping and data aggregation abilities of Pandas, as well as its scraping capabilities and general input-output capabilities, which are diverse. In this video, we're just going to do a small kind of introduction to Pandas to give you an idea of what the API feels like before digging in more conceptually in more conceptual depth as well as more technical depth in the subsequent Pandas lectures. So I said that Pandas is a powerful tool for working with tabular data or data tables. This meaning data that follows the pattern where each row of our table corresponds with some object, event, or idea, some kind of noun. And each column is a property of that noun, some attribute. And this is sort of analogous to how we described objects in Python. Objects are instances of a class with attributes and methods. In this case, we're only dealing with basically attributes. So each row of a data table is an instance of some kind of object, and the columns are basically different attributes of that object. And this doesn't apply to Python. This is a general idea about how tables should be structured and interpreted. This is also used for the theory of relational databases and using SQL, which we'll also talk about in a future week. And we have all had experience, I'm sure, working with data tables. It's probably almost second nature, and we probably don't think through a lot about how tables are set up. But as we work with Pandas, we'll see that we rely on these shared notions for structuring the syntax of how Pandas tables should work. So in the previous example, where we plot in the video on matplotlib, where we plotted data about a football team, their chest sizes and their shoe sizes, we had a array, a one-dimensional array dedicated to their shoe size and a one-dimensional array dedicated to their jersey size. But these were in separate data structures. And if we wanted to put them in the same data structure, we would have to remember, was shoe size in the first column or jersey size in the first column? This is a similar problem to what we had when we introduced lists. When we store data in a data structure, it can be inconvenient to rely on positioning or order as our only source of organizing the data in the data structure. It can be very helpful to be able to name the fields or objects in our data structure. So just like a dictionary enabled us to label the elements we put in our data structure, a data frame, which is the table, the Pandas table, it's called a data frame, is going to allow us to store these two one-dimensional arrays, shoe size and jersey size, as a two-dimensional array that is labeled with meaningful names. So let's have a look at that. We'll import pandas as PD. That's the conventional abbreviation for pandas, just like PLT is the conventional abbreviation for matplotlib.pyplot, or NP is the conventional abbreviation for NumPy. These are very strong conventions. Almost everyone who uses these packages uses these abbreviations. So we'll import pandas as PD. We'll generate our football team with their shoe and jersey sizes. And I've taken a bunch of names of famous football players to label the different rows of the table. So, for instance, we have Pele's jersey size and shoe size, Lionel Messi, his jersey size and shoe size. And of course, these aren't their actual jersey sizes or shoe sizes. They're just randomly generated. But I can now refer to these different measurements as being jersey sizes or shoe sizes, and as belonging to particular players. And I can access these numbers by using these meaningful names. And this is a huge upgrade from the NumPy array that underlies this data frame data structure. With the NumPy array, I would have to remember that Zinedine Zidane is the fourth row and that the jersey size is the first column. With pandas, I don't need to remember that because I have meaningful labels that I can use to manipulate the data. We can see here the one syntax for creating a data frame. We'll be displaying more syntaxes when we talk about when we do the lectures from the Pandas notebook. But we can even see this relationship with dictionaries that I was using in the earlier analogy, where the data series, the kind of list of shoe sizes or jerseys, those arrays, are the values in this dictionary of columns. So this data frame is constructed as a dictionary of data series. And then I supply an index, a special column of labels for the rows. The index labels the rows. There are other ways of creating data frames. I'm not going to spend more time on them at the moment. But just like we highlighted in the data structures notebook in the Python module, that we could construct dictionaries using zip and zipping together a list of keys and values. We can do similar but different, a similar but different approach in this case. So let's see that description I gave earlier in action, where I said we could use these names to access elements of the data frame and access our data. So here we have our data frame, df, data frame, df. That's another convention. We should always give our variables meaningful names. This is a good kind of default name for a data frame, but we might also want to call this, for instance, team or team df. So a data frame containing all the information about my team. I'm not going to make that change, so I don't have to change the other code. But just as an example, we always want to remember to try and give meaningful names to our data. And if we have multiple data frames that we're working with, we should distinguish them with good variable names. So I'm going to take that data frame df, and I can access it using that kind of dictionary-like syntax that we had seen in the past. So I'm going to slice into it with square brackets, and I'm going to give the column name as a key for what I want to get out of here. So the column names are sort of keys to the data frame. The data frame is is a dictionary of data series. So if I want to get out the shoe size data series, I can slice into the data frame using the appropriate key, shoe size. And I get back this object, which in fact is, just as I called it, a data series. We see pandas series. So there's a pandas data frame object. There's also a pandas series object, and the series refers to a single column in a data frame. We'll explore that a little more in the subsequent lectures. And since data series are built on top of NumPy arrays, we can easily apply functions to the data frame using a very similar syntax as we saw with NumPy. So now our understanding of NumPy is paying off. That logarithm gets broadcast to the entire data frame. And we compute the logarithm element-wise for every element in the data frame. We can also compute means. In contrast with NumPy, mean doesn't compute the mean of every value in the data frame because the data series are sort of distinct. They have different meaning. That's why they're different series. And since they have different meaning, we calculate the means for them separately. So we get the mean jersey size and the mean shoe size. So we've seen we can retrieve columns by name. Retrieving rows by name works slightly differently. We use the lock method of a data frame to get the row by name. And in fact, lock is very flexible. We can not only retrieve a particular row, but we could also retrieve a particular column. So Ronaldo's shoe size is this 8.79. But if we wanted all the information about Ronaldo, we could get his jersey size and shoe size by just picking out the entire row. But again, this resembles sort of a dictionary-like syntax. We have the .lock method, but then we have the square brackets, and we refer to the row we want by name. We can also select multiple rows or multiple columns by passing in a list of names that we want to slice out. Or we can use true slicing based on positions of the rows in the table. So between George Best and Ronaldo, there's Yaya Touré, Diego Maradona, and all these other players who are between Ronaldo and George Best in the data frame. So we slice out all of them from Ronaldo to George Best. Notice George is included in the slice. This is in contrast to list slicing by index, and that's because there's no sense of like what's before George Best. Since it's based on a name, we get the name that we asked for included in that slice. There's also position-based indexing. I'm not going to spend time on that because the fact that we can apply labels, meaningful labels, to the rows and columns of our data frame is very powerful, since those labels communicate meaning to us and help us organize our own thinking about the data. So it's very rare that we will use position-based indexing rather than indexing by name. But it works roughly as you would expect, and by playing around with these, I'm sure you can figure it out. I'll describe it more in a subsequent lecture, but I want this overview of pandas to be brief. We'll go into more detail in the future. We can also view just the top or the bottom of a data frame. If we want to get an idea of what it looks like, we'll usually not want to represent the entire data frame to us, which may have many hundreds or thousands or hundreds of thousands of rows. or many columns, maybe dozens of columns or hundreds of columns. So head and tail will just give us the first and last 5 rows, or we could ask for more rows. We could ask for 7, for instance, and we'll get the first 7 rows, the head of the table. So you can see in the DW mini project, for instance, I use head to visualize the format of the tables that we load in. I will be providing an intro to the DW mini project video as part of the lectures this week. We can also add columns using, again, a dictionary-like syntax. We index into the data frame at the key of the column we want to create. This random choice is from NumPy is going to randomly choose positions for each player. And it's going to choose one position for each row up to a number of rows equal to the length of our data frame. So we can see now that new position column where we've assigned Ronaldinho to defense, Pele to midfield, Messi to attack, Zidane to attack, Drogba to midfield, etc. I have no idea of whether these would be good positions for them or not. They're all quite talented, might not be ideal, but this just illustrates how we can create a new column. We can also add a new row, similarly using lock, just as we did before to access data, now to assign data. And if we want to remove these elements from the data frame, we can drop them. So to drop a row, we'll drop the row and give the index of the row we want to drop. So we can see, even though I just added Dylan to the data frame of players, once when I drop him, he no longer appears in the output. Or I could drop a column by giving the name of the column and specifying that I want to drop a column using the axis equals 1 keyword. So now I've gotten rid of the positions. But if we notice, I'm back still in the data frame, even though we had just executed df.dropDylan. Most data frame methods return a copy of the data frame. They do not tend to mutate the data frame. If we want to make that change permanent, we can either assign the result returned by the drop method to the data frame itself. So we overwrite the data frame with the new version, like so. Or we can turn the drop method into a mutation by specifying inPlace equals true. So now both Dylan is gone and we drop the position column. As I've mentioned, we're going to explore pandas in much more detail in an entire notebook dedicated to pandas. But this gives you a brief overview and hopefully gets you comfortable with looking at data frames and thinking about interacting with them as objects, and gets you acquainted with this idea of a data table in Python.